Now we will discuss about design of a stator. So we will go very fast. Please keep noting. So now design of a stator. We are having the 0.35 to 0.5 mm thickness steel lamination, HRS or CRNOS, not CRGOS. If length will be more than cooling ducts every 10 centimeter gap. If length will be more than cooling ducts should be every 10 centimeters. So this is the stator core, this is the stator core, this is a stator tooth, and this is the stator slot. Stator lamination, this is the complete lamination. This is stator core. Once again I am repeating, this is stator core, stator tooth, stator slot. So this is the complete stator lamination. Stator winding, double layer LAP type winding with diamond shaped coil are used for large motors. Double layer lap type winding with diamond shaped coils are used for large motors. 2 conductors per slots. 2 conductor are used per slots. So stator winding for medium and small motors, single layer must type winding are used. Each coil occupies 2 slots. For medium and small motors, single layer must type winding are used. Each coil occupies 2 slots. Now the 3 phase of the stator winding can be connected either as a star or delta depending on the starting method employed there. Squirrel cage induction motor normally use star delta starter, and it is based on the rating of the motor and requirement of the customer. Accordingly we are using that. 6 leads are taken out of the motor through the terminal box. For that 6 leads are taken out of the motor through terminal box. And if you talk about 3-pling induction motor, they are started by rotor resistance starter. Stator can be permanently connected as star or delta as desired. So now calculation of stator turns TPH. Calculation of stator turns. Flux per pole phi. Flux per pole phi equals to BAV tau into Li. BAV tau into Li. Now pole pitch equals to tau. Pole pitch tau equals to pi d by p, and phi equals to flux per pole equals to B average into pi d by p into Li. So net iron length equals to Li. Net iron length Li. Li is denoting net iron length Li. B average, that is flux. So now we can calculate phi equals to B average pi d by p into Li. Now we already know induced EMF per phase equals to 4.44 F into phi into TPH into kW. Induced EMF per phase EPH equals to 4.44 F phi TPH into kW. Neglecting the voltage drop in the stator, EPH equals to VPH. So we will get the value of TPH equals to VPH by 4.44 F phi kW. And in terms of D and L, if we write VPH into P by 4.44 F into BAB pi DLLI into kW. So total conductors Z equals to 3 into 2 into TPH, that is equals to 6 into TPH. Total conductors equals to 6 into TPH. Selecting number of stator slots. Proper selection effect. You can say proper selection effect. Operating performance, weight of the machine, cost of the machine. These all things are affected by it depends on the selection of the stator slots. Operating performance, weight of the machine, cost of the machine. There are no any fixed rule there that these are the thumb rule or these are the you can say that very important rule that has to be followed mandatorily. So it is not there. Stator slots, open slots, semi-closed slots, tapered slots. Three kinds of slots are there. Open slots. Open slots are easy winding repair, easy assembly, but higher reluctance. Poor power factor will be there. These are some feature of the open slots. And once again I am repeating, easy winding repair, easy assembly, but higher reluctance. Poor power factor. Semi-closed slots. Assembly is difficult. Uniform air gap. And the third one is tempered slots. Now some of the advantages, I am going to tell you the sum of the advantage of number of stator slots. Sum of selection of number of stator slots. What will happen if there will be large number of stator slots? So advantage of large number of slots, that will reduce the leakage flux. That will also reduce the leakage reactance and reduce the tooth pulsation loss. I am once again repeating, advantage of large number of slots, reduce the leakage flux, reduce the leakage reactance and reduce the tooth pulsation loss. Some of the disadvantages are also there, and if you can note down, you can write. Disadvantages are increased cost and weight of the copper coils. कॉस्ट और वेट दोनों बढ़ जाता है कॉपर कॉइल्स का. टीथ थिकनेस विल गेट रिड्यूस्ड. दैट मीन्स मैकेनिकली वीक, दैट विल रिमेन मैकेनिकली वीक. more corrosses will be there and more magnetizing current will be there. The effect or the impact of teeth thickness reduction is mechanically weak, more corrosses and more magnetizing current. Now another disadvantage is efficiency reduced. Efficiency will get reduced. Cooling will get hampered and temperature will be rise more. That means temperature rise will be more. So guideline for selection of number of stator slots. Number of slots per pole per phase should be multiple of 3. Number of slots per pole per phase should be multiple of 3. Integral slot winding. There can be fractional slot winding also. So stator slot per pitch at air gap. Stator slot per pitch at the air gap. That means tau Sg equals to pi d by Sg. That will be equals to 1.5 to 2 to the power 2.5 cm. Tau Sg equals to 1.5 to 2.5 cm. Guideline for selection of number of stator slots. Number of conductor per slots must be even. Number of conductors per slot must be even. That is double layer winding. Zs equals to 6 Tph by Sg. This indicates the top coil side and this is the bottom coil side. So Tph, turn per phase. This one is the top coil side and this is the bottom coil side. So you can just see there the turn per phase. Now the question will arise and the question will come. Write down the question. Determine the main dimension, number of radial ventilation duct, number of stator slots and the number of turn per phase of a 3.7 kilowatt 400 volt 3 phase 4 pole 50 Hz squirrel cage induction motor. Assume average flux density at air gap to be 0.45 Weber per meter square. Ampere conductor per meter 23,000. Efficiency equals to 85%. Power factor is equals to 0.84 and stacking factor equal to 0.9. The motor is to be sold at competitive price. You have to always keep in mind the cost implication. The pricing part you have to always keep in mind. So a squirrel cage induction motor are normally started by dual or star delta method. Thus under running condition the motor connection is delta only. Under running condition most of the motors are connected in delta only. So ns equals to 120 f by p. 120 f by p. F is the frequency, p is the pole. So 120 f is the frequency, 50 hertz. Pole is the 4-pole machine. So 1500 rpm will come. Now small ns equals to ns by 60. So 1500 by 60 equals to 25 rps. So c naught equals to 11 bav ac into kw eta cos theta into 10 to the power minus 3. Now putting all the values you have found out here, c naught equals to 11 into 0.45 into 23,000 into 0.955 into 0.84 into 0.85 into 10 to the power minus 3. If you will calculate, then it will come 77.6. So you have calculated c naught, value of c naught. Now you can put this c naught value in the output equation. Q naught equals to c naught d square ln s. So now d square ln l will come as 3.7 equals to 77.6 d square l into 25. So d square l equals to 0.00191. So for minimum cost, that means if your machine will become competitive in the market when L by tau equals to 1.5, so L by tau equals to 1.5, that is equals to LP by pi d, d square L equals to 0.00191, L by tau equals to LP by pi d equals to 1.5. Now L by d 1.1775. Solving for L and D. Now solving for L and D, we will get D equals to 0.1175 meter and L equals to 0.1383 meter. After each 10 centimeter length, we need one duct. After each 10 centimeter, we need one duct. Since L equals to 13.83 cm, there will be one duct in the stator. There will be one duct in the stator. Thickness of that duct will be 10 mm. Net iron length equals to 0.9 into 0.1383 minus 0.01 equals to 0.115 meter. So in this way you can calculate and you can get the result. Turn per phase, flux per pole phi equals to BAV Li into tau, pole pitch. Once again I am repeating, tau equals to pi d by p. So pi into 0.1175 by 4 equals to 0.092. So phi will lastly come 4.76 into 10 to the minus 3 Weber. Since the machine is delta connected, so Vs equals to EPS, that is voltage equals to induced EMF, that is equals to 4 volt. So turn per phase, TPH equals to EPH by 4.44 F into phi by kW. So 400 by 4.44, 50 into 4.76 into 10 to the minus 3 into 0.955, that will be approximately 3.96. So now the last thing I am going to discuss, number of stator slots. Number of slots per pole per phase should be multiple of 3 for integral slot winding. Let us take the value Q as equals to 3. Total number of slot SG 3 into 4 into 3, that is 36. And a stator slot pitch pi tau SG pi d by SG, pi into 0.1175 divided by 36, that will come 10.25 mm. The guideline was slot pitch to be between 15 to 25 mm, but for smaller machines it can be lower than 15 mm also. Thanks, have a nice day. Now we will continue in the next lecture.